We'll be talking about data summarization in this lecture. So again, if you go to johnmichelli.com/intro_2_R, you should be able to see the slides. We will be looking at day 2, data summarization, and I'll be using the HTML slides for this lecture. Okay, so let's jump in. So some basic statistical summarization. These are some functions that take in vectors and return some sort of summarized output. So mean, if you put in a vector in there, it takes the mean of those values. SD takes the standard deviation, essentially takes x minus x bar, the sample mean, squares it, divide by n minus 1 for n being the number of elements in x, and then takes the square root of that. We will talk about missing data and how it incorporates these things in a little bit. Median takes the median of that vector. Quantile displays the sample quantiles of x. The default is the min, the interquartile range 25, 50th, 75th percentile, and the maximum. The range, it gives you a 2-element vector back. That is the min and the max. The min is always first, the max is always second. Sum, the sum of x. All of them have an na.rm argument for missing data. That's going to be discussed later, but that allows you to calculate these removing missing data. We will talk again that in R, if you think as a statistician, a missing value, you don't know what it is. So if you take the mean of 10 values and one that's missing, that value could be 100 or 1,000,000. R doesn't really know. So by default, just to be safe, it says, hey, that's unknown, right? So if you think of it mathematically, that is technically an unknown number because we don't know what that last number could be. It could be negative 1,000,000. It could be positive 1,000,000. It could be a lot of other things. And it says, hey, I'm warning you. Well, it doesn't actually give you a warning, but it gives you a warning in the sense it returns an NA saying, hey, I don't know what you want me to do. You have some weird value in there that's missing. Unless you tell me explicitly, I'm not going to remove it. I'm going to report back that there is an NA in there. So there's other transformation function. Log takes the log base e transformation, log 2, log 10, just log with different bases. Square root function, again, remember, if you take the log of a 0, you will get a negative infinity. So we will use the JHU cars data set and explore some of the different ways of summarizing data. If you say library JHUR, the JHU cars data set should be available in memory. So here again, I'm using head just to show the first 6 rows. So the first column is the car, then we have the miles per gallon, the cylinders, the displacement, horsepower, and all these other different things like is it an American car, and the number of gears, the carburetors, and so on. So again, we will be using the $ to reference columns from a data set. So remember, all those functions I showed you in the very first slide take X as a vector. It takes a vector of arguments. It takes a vector of elements, right? So here, we can't just put mean JHU cars. We will talk about how to do that summarization in a tidy way, in a dplyr way in another lecture. But here is a very simple thing to say, or in another set of slides a little bit later. But here we're taking the mean horsepower over the entire data set, and we see that the mean horsepower is 146.6875. Again, we could do the quantiles, which will give us the quantiles, which is a named vector, which has the name 0%, 25%, and so on. So we can also do median. Let's say we want the median weight. I believe this is in tons. Similarly with the quantile, the function, there is an argument that allows you to estimate which probability, which quantile do you want to give back. So maybe you don't want the min, the IQR, and the max. Maybe you want the 60th percentile, the 60th quantile in there. So you can say probs equals 0.6. You can also pass in an entire vector of different quantiles to have R report those back to you. So t.test, we will be covering more in this statistics lecture, but t.test is also a very quick and dirty way to give you an estimate of the mean, also with a confidence interval. So let's say I want the mean, but I also want a confidence interval around it. You say t.test, and again, we're going to pass in this vector. We're doing a 1 sample t-test, gives you the t-statistic degrees of freedom, a p-value based on some normality assumption of that data, some it gives you the alternative hypothesis, a 95% confidence interval, sample estimates, and then we're going to use the function tidy from the broom package. So you can think broom, what do you do with a broom? You tidy things up. If we pass in that whole object, that t-test object, it'll turn it into a data frame so we can use the functions about data manipulation like mutating and things like that from the dplyr package. So some of the things we will be talking about in this course only work on data frames, and broom has a function called tidy, which really allows you to take a lot of the things we want and have as output and turn them into data frames. So again, all these arguments or all these functions about data summarizations that I've talked about in the first slide have an na.rm argument to remove NAs. So here we're going to define a vector x to be 1, 5, 7, some missing value, 4, 2, 8, 10, 45, 42, and we take the mean of that. Again, that NA could be negative 455,000, that NA could be 0. So if you take the mean of that, because this number is unknown from a statistical point of view, this is unknown. It could be anything. Now, it's also just as a stopgap measure, just so that it alerts you in some respects that your data has missing values, because missing values can be a huge issue when you're doing analysis if not accounted for correctly. So here, if we say mean of x, but we say na.rm equals true, again, passing in a logical, we say yes, remove the missing values, and it gives you 13.7778. Now, it doesn't put the NA to be 0. It does the denominator correctly. So it takes, the number of elements of X that are non-missing. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it averages over 9 values instead of the 10. It doesn't do any funky things in there. It just removes this value and then calculates the mean. So the one difference I will say between the mean, the quantile and the rest of the functions, if you don't put this as na.rm equals true in there and you do have missing values, it's going to give you an error. Whereas all the other functions are just going to say, hey, that's an NA. This one's actually going to error out. So you have to make sure that you put na.rm equals true to get anything out that does an error. But again, for all these functions, this is what you want to set. If you know you have missing data, but you just want to ignore them. So there are some different summarizations that can be somewhat useful if you have like a big data set that's like very, almost all the columns are numeric or something like that. So there's row means, which takes the row means of each row. Column means takes the means of each column. And the output of row means will have, if you have n rows by p columns, you'll have n elements here. If you take the column means, you'll have an element for each column. So you have p objects out of that. Similarly with row sums and col sums, all of these arguments as well, or all these functions as well, have an na.rm function argument in there to remove NAs. Summary for data frames, we'll be using summary a lot more with respect to models, but for data frames, it gives you some information about the quantiles and it gives you some information about, how many missing values and things in there. So there's an additional package called the matrix stats package that has additional row and column functions like row standard deviations, column quantiles, things like that. So if you say, I love these functions, but I wish there were more, matrix stats pretty much has the ones that'll fill in what you need. Okay, so we're going to pause here and go to lab part 1 of the website. So again, if you go back to the website, you should be able to go to data summarization once this loads. And you should be able to pull down the key, the lab, I apologize. The key is also up for now, and it should open up and you should see a marker that says part 1. So again, for all of these labs, I would highly suggest for the first question, just clicking this down arrow to run all the code chunks above, because we have code in there to load in the data you'll need for this lab. And so it'll already be preloaded. And so now you can do whatever you need to do for this lab and not have to worry like, oh, is this loaded or not? Hitting this down arrow will load all those code chunks. So let's take a minute and do that lab. You can pause here in your video and then I'm going to move on. So we are going to be using for this lecture a data set that is very numeric. It's got numbers in all the columns that mean something except maybe the first one. So this is a data set about tuberculosis incidence, and we are going to read it in because it's an XLSX file into our using the read_Excel function. If we had downloaded it, but alternatively, it is a data set in the JHUR package. So you can use the read_TB function, and that will output the data set. So here we're just viewing the column names of TB. So we see the first column is this TB incidence, all forms, parentheses per 100,000 population per year. Now this column is totally fine, but it has a whole bunch of things we might not want in a column name. It's got spaces, it's got commas, it's got parentheses, right? It's got numbers and spaces inside of it. You know, maybe this isn't the way we want to go. We probably want to rename that first column. And if we actually looked at the data, that column is the country. So if we looked in the viewer and said, hey, you know what? This is the country that we actually want to rename the thing to, we can load up the dplyr package and we're going to use the pipe. So again, we're going to take the data set, pipe it into rename, because all dplyr functions, the first argument is the data set. And now again, rename, like we talked about the data IO lab, new equals old. Now, the nice thing about using the dataset pipe in RStudio is if you do dataset pipe rename country equals and hit tab, it'll allow you to tab through all of the names of that dataset. And the first one that'll come up is TB incidents, all this thing. So you don't have to remember it's this long form name. You have to copy and paste this in from somewhere or remember it. You can use tab completion. And now, if we look at the column names of this dataset, the first column is country and the rest of them are years. So each of these columns represents the TB, tuberculosis incidence, for that country if it has any data. So again, you could have put this in quotes, single quotes, double quotes. You could also put it in backticks, and that's what RStudio will do by default. That's what came out here. But again, you have to encapsulate it by something special because it's got spaces and all these types of funny characters that column names make it a little bit difficult to work with. They're kind of special characters, especially the comma, the spaces, the parentheses. So again, you have to encapsulate it in quotes, single quotes or double quotes, or backticks. So although we talked about the functions, mean, median, and quantile and all those types of things, we will be using the summarize command. So summarize can be spelled with an S or a Z. The creator of this, Hadley Wickham, one of them is from New Zealand. He spells things with an S. And I would actually highly recommend learning to use the summarize with an X function because there are other packages you may load up. One of them, namely, is called the HMISC. So capital H MISC package, which is really useful. But if you load that, it also has a summarize command, but dplyr only has one, is the only one that has one with an S. So there'll be no conflicts if you load both packages at the same time. Now, like I talked about this first column having all these funky things, again, columns of a data set, they are allowed to just be numbers, but when they start with a number, it's a special column, right? So generally what you don't necessarily want to have in your data set is columns that start with anything like exclamation points or dollar signs or any funky characters, but they also probably shouldn't start with a number. If they do, you have to encapsulate them in quotes, just like the other thing, because they're kind of special. So here we're taking the data set, we're going to pump it into the summarize command. I'm going to make 3 columns. One of them is the mean of the 2006 data. And again, because I know there's already going to be some missing values in this data set, then I'm going to say na.rm equals true. And this should be median, but I missed a letter here. So media underscore 2007 is the median of the 2007 data. And then we are going to take the median of 2004. Now note, these are new columns I'm creating. So just like the mutation and mutate command we talked about before, you can say new column equals summarization in this instance. So mean this equals the output of this. So if you don't do that assignment, you'll see what happens here. So again, we get the mean of 2006, it's just one number. Median of 2007, it's just one number. But because we didn't assign this anything to the output, it says, hey, you gave a command that gave something back. You know what I'm going to try to do? I am going to actually make this a column, and I'm going to try to use all these words as the column name. I mean, it looks a little funky, but that is what's going to come out. So usually you want to set on the left-hand side what the new column name is going to be. But for example, the median 2004 TB incidence is 56. So again, column means and row means must work on all numeric data. So Here, we're going to use the select command. We could have piped it in there, but we're using some of these select helpers. So we're saying this data set, I want to select any column that starts underscore with 1. So this starts underscore with is a select helper function that allows us to easily grab columns of a data set. So I'm grabbing anything that starts with a 1. So it's 1990 all the way up to 1999. Now I've removed the country column and I have all numeric columns, and I can say col means on this data set and say na.rm equals true to remove any NAs. Now, that being said, 1990 and 1999 might have different levels of missingness. So this 125, is still a good estimate probably for 1999, but it might have, 10 more countries in the data set because they recorded TB incidents, whereas in 1990 they may not have. So just be aware, although column means removes the NAs, it doesn't remove them through every single row. It removes them column-wise. So again, we can assign things like this. We could also use the mutate function that we've talked about before, but this is a shorthand way. Again, TB $, making a new column equals the row means of these averages. And again, I'm going to remove any missing values. So again, this is the mean TB incidence for all the data from 1990 all the way up to 1999. And again, if we go all the way back to all the column names, we see that the data goes from 1990 to 2007. So actually, this is technically all the data we had before 2011, the average. But again, if there were something from before, 1000 AD, I don't know, we would have to modify this code a little bit because that technically wouldn't be the before 2000 average. And if we look here, just subsetting these two columns, we could have used select again, but this is just some shorthand just for printing out. So we look Afghanistan, before 2000, the average TB incidence was 168. Albania was 26.3, given the TB incidence data we've pulled in. So again, there are other functions that allow you to do a little bit more wholesale summarizations. So some of this has been superseded by the across function in dplyr, and we will try to get something out to you that maybe makes this a little bit more intuitive, but the SummarizeAll function is still very useful in my opinion because it's pretty explicit what you want to do. So again, given the dataset's first argument, it's dplyr function. So you know that. So we're putting in this averages dataset, and then you tell it the function. So this function is the mean. I want to take the mean of every single column. And you say na.rm equals true because this is an argument you can pass to this function. Okay? So if you want to pass additional functions to the function you're giving, you can put them after the comma, but they should be named. Okay, so na.rm equals true is a argument of this function. It's not an argument of SummarizeAll. It's referencing this function, but we're taking the averages data set, which again is from 1990 all the way to 1999. And if we look back at the slide before, these should give us the exact same estimates as we had done, except they're rounded for a little bit because this is actually a tibble that comes out. So let's go back. This is a vector of named arguments. So this is a vector. So things that work on vectors will work on this. But if you need something that is a tibble, then this will work, or a data frame, because even though it has one row, the class of it, the data type that's outputted is a data frame or a tibble. So again, the summary command can give you some rough snapshots of each column, but you probably use mean, min, max, quantile when necessary. I think this is a pretty okay view at some of the data columns, but sometimes a little too much information, and it's usually information that I don't want, or if I want to do it, I only want a subset of this information. But one nice thing, it tells you the class, it tells you the mode for specific character vectors, but it tells you the number of NAs for different columns and also a breakdown of the quantiles. So again, we'll be going back to the tobacco survey, which we've explored in other capacities. But again, it is a survey of teens and their tobacco use, whether it be smoking or chewing tobacco. And the JHUR package has that data encapsulated. If not, we could have read this in using read_CSV from readr. But here we're reading YTS. And again, we have a data set where it's year is the first column in all caps, the location, different types of questionnaires and measures from the smoking cessation or chewing tobacco use and things like that. So unique is a very powerful function. It does, I would hope, what you'd expect it to. It takes in a vector of objects, usually of a vector, but it can also take in a data set, but we're not talking about that in this instance. You say unique, YTS, $ location description. That will give us all the unique locations. They will be sorted in the order in which they're found. And then again, head, we're just showing you the top 10. So let's say we want to know how many unique locations are there in this data set. So combined with length, this is a very powerful combination. So this gives you the number, the vector back of unique locations, and length tells us the length of that. So we see 50, so we say, hey, maybe that's the 50 states. But we look up here and we see the 10th is national estimates. So there have to be some missing states in this database because we have national estimates average over a whole bunch of things, including DC, but we only have 50 unique elements in this. So some of the states have to be missing. So table is a very useful function for giving you a frequency table. There's a function we'll be talking about in dplyr called count, but many times just a simple table of frequencies is helpful to explore your data. And again, we're just showing the first 6 elements. The one thing I will say about table is it does order these things by alphabetical order. And again, we'll be talking about factors or categorical variables in the future and how those things are ordered. So if this was a factor, if this was a categorical variable where you said these are the levels, the table would come out in the levels you specified, not alphabetical. So the count function is a little bit tidier way in the dplyr way of doing things. Again, you can pipe in the data set, and again, because it's a dplyr command, first argument's the data, and then you specify which column you would like to count up. So again, when you're using table or some of these base functions, you have to pass in vectors usually. So you have to use the $ notation. But when you're using dplyr, it does some smart guessing. It says this column, this thing you're passing in is a column from this data set. So again, if we're going to say youth tobacco survey and we want to count up the location descriptions. So again, it'll give us a simple frequency table, but again, compared to this is a vector, this is a tibble. So this can work on all the other dplyr functions, which is why it's nice that that is the output. Now, if you put in multiple variables, it will give you a frequency table with all the combinations of age and location description. So although before, we see, and they're ordered in a specific way. So in this case, I believe the column here might just be all ages, but if this was another factor that had like 30 to 50, things like that, it would be this row represents this Alabama, this location, age combination. That is how many unique elements are in that combination of things. You can put in 3, 4, 5, 6 different things, in there, and it'll give you all the combinations in there. Table though only works with one-dimensional vectors or two-dimensional one vector at a time or 2 vectors at a time, but they will be very useful in the future when we talk about doing testing on tabular data. So like Fisher's exact test or chi-square test, things like that. Okay, so again, we can do some data manipulation here. We're going to load up dplyr again just to make sure it was in there. We're going to take the youth tobacco survey data set and we're going to filter by the measure description to be smoking status, the gender to be overall. We don't want it broken down by men or women. The response to be current, so they're a current smoker, and their education is middle school. So this is usually teens or younger than teens who are in middle school. And then that is the rows. We filter again on the rows, these conditions when they're all met simultaneously, because again, we didn't use ands or ors, but when you just separate things by commas and filter, implicitly you're saying this and this and this and this. So it has to be smoking status and gender equals overall and so forth. And now we're just going to select certain columns. Again, we could be using the pipe in these instances, but we're just not. So we're saying select, first argument's the data set. I want to grab the year, location description, data value, and data value unit. And again, select will grab those columns. And here is what we're looking at. So here, the year is 2015. Arizona, the data value is 3.2 and it's percentage. So 3.2% of middle schoolers, overall gender, are current smokers. So group by is probably one of the most, if not the most revolutionary things that dplyr did. So it allows you to group the data by something so that certain other functions can operate on it differentially. What do I mean by that? It's like maybe you want to summarize the mean age or the median income or something like that, but you want it broken down by group. Group by can do that. Also, let's say you have patient data and you have 5 records per patient, and you want to say which one is the minimum, visit date. So, but let's say you don't want to condense the data down. You want to mutate that data so you have a column that's like visit one date, and it replicates that over and over again for each patient. So you group by the patient, and then you can summarize by the first date or the minimum of the dates. So here we have done nothing. All we've done is reassign sub YTS, and we've grouped it by the year column. So nothing has changed in the data set whatsoever, except for this attribute that says these are the groups that we've assigned to it. Now, this is, again, one very stark difference between a tibble and a data frame. Data frames can't have groups, tibbles can. So now this is a group data set on the left-hand side. Now we're piping it in here, and we're saying we're going to calculate the year underscore average, and that's the mean data value, and we're going to remove any missing values that we see in there. So now, if you had done this before and you didn't group by year, you would just get one number out. It's just going to be the average of all the data values. But here, since we grouped by year, we get an estimate per year. And Summarize, again, will condense the data down to the number of groups and get the estimate that you want. So I think the nice thing about group by and Summarize with pipe is this code, I would say, is pretty relatively intuitive to read once you know what's going on. You take the youth tobacco survey, you're grouping it by year, and then you're summarizing it, getting the median and the mean. And if we look at it, we see now we have one row for each year, and now we have an estimate for the average and the median. But this could be year and location. It could be, you could group by location first. You could do a whole bunch of different things, just like you did with count. You can group by multiple things, and then you can calculate estimates based on those different strata. So sometimes you don't want to do things like I said before. You can group the data by something and you can mutate it. You can actually make a new column that calculates that thing by each level of the group that you have. Sometimes you want to do summarizations like we did here. And sometimes you want to get rid of the group. Say, I don't want to do anything in this group anymore. So if you regroup the data, so for example, if you run group by again later on this this data set, it will supersede the previous groups. But if you just want to say remove all the groups, there is an ungroup function to do that. So again, like I was talking about, group by isn't just powerful with Summarize. It can also be powerful with mutate. So here we're grouping the data by year. We're calculating the year average, and we're arranging the data by the location description and the year. So if we look at here, we see 2000 Alabama has 19.1% and the year average to be 12.5. Now we see 2000, right? These are the same year, 2000, different state. This is the state estimate. But again, it filled in the exact same value for the year average because it grouped the data by year, calculated the average over all states, all locations, and got the average and put it in there. So it repeated that measurement multiple times, but sometimes that's what you want. You want to be able to compare this to the general average or something like that. So there are other functions which are pretty useful, such as n, which will count the number of records. So sometimes you just want to use count, but when you summarize and the n function together, it can give you more powerful things than just counting, right? So we could have just done count year, and that would have given us a frequency table of the number of records that had the year 1999 and so forth. But we wanted the counts and the means together. Note, though, that if there are missing values, there is a mean of those values, and it removes them. This does not say anything about missing values. So it says, how many records in your data set do have the year 1999? But some of them could be missing. So that doesn't necessarily mean 14.6. This average was over 10 values. So you have to use things like sum and is.na, which is a missing variable indicator, to really be able to see that. Also, just note that we just piped this into the head function, so it just shows those first 6 records rather than printing everything out. So now we're going to move on to the lab part 2, and you can pause here and we should be able to go to the website and move on and go through those specific questions. All right, moving on. So data summarization. One crucial aspect of data summarization is actually plotting, visualization. So tables are great, but plots sometimes are good just summary of the data. We will be using the ggplot2 package, which stands for the Grammar of Graphics. This is a package that was developed by our studio in Hadley Wickham. It is a fantastic package, one of the best plotting packages out there. It can become intuitive over long-term use, but when you start out, we would suggest at least trying qplot, which stands for quick plot, which gives you some basic plots. So arguments that you put in there, X, Y, the data set, these things called facets, which allow you for different panels. And again, remember lecture 1, lab 1, we showed you a multi-paneled plot of the circulator data, and we changed different colors and things like that. Geom stands for geometry. What do you want to plot? So that can be histogram, it could be box plot, it could be points, it could be lines, it could be a combination of the two. And there's other arguments like what do you want to label the x-axis? What are the x limits you want to keep? What are the y limits you want to keep? What is the title of the plot that you want to make? So plotting is an important component of exploratory data analysis. It allows you to explore the data in different ways and develop and see relationships. We will review some of the more useful and informative plots here. We will go over formatting and making plots nicer in additional lectures, especially the visualization. Now, drive that point home. To be able to make an effective plot, you just have to be able to do it quick. Say, oh, that's what that looks like. Oh, there's no weird values there for summarization of the data. Now, when you're going to make publication level figures, it takes a lot of time and energy. So again, we're going to load up the data, the package ggplot2 using the library command. And here we're going to say qplot. We're going to say x is displacement, y is miles per gallon, and we say data is JHU cars. Right. So putting that all together, it guesses. I showed you before, we see geom equals auto. So if you give it an x variable and a y variable, it's going to guess and say, hey, I bet you want to do a scatter plot with some points. So again, displacement on the x, miles per gallon on the y. We could switch the order of these, but as long as we said y equals mpg, x equals this, it'll give the exact same plot. But if I said x equals mpg, y equals displacement, it'll flip the axes. So here's an example. If we took that TB data set and we said, hey, I want you to plot the before 2000 average column from that data set, and I want to explicitly say it's a histogram. So here we see a histogram that has some automatic binning in there, which you can change, but this is a distribution of what the before 2000 average looks like. So you can also give it an X, give it a Y. So here, X is the year, Y is the year average. Here we're going back to the tobacco survey. We're just flipping back between data sets just to kind of explore different aspects of plotting. And we can be explicit and say geom equals line. So before, remember, it automatically guessed that it wanted a scatter plot, but if we explicitly say geom equals line, it gives us a line plot. Now, another thing we could do, so before we did a histogram, if you give it just a single X vector and don't ever give it a Y, but give it a data set, it'll by default try to do a histogram. You can also do a kernel density estimate, which is something similar to a smooth histogram. But if you integrated this whole thing, it would sum to 1, so it's a proper density. But this gives you an overall idea of the shape of the data value from the subset of the youth tobacco survey. And again, these are current smoker rates for those who have attained middle school. So here we're plotting on the x-axis the location description. Again, these are the states plus some national averages in DC. The y value is that current smoker rate for those teens or children. Again, we put in the data set, but here, instead of doing anything else, we're going to put a box plot for every single location description. So we can see the overall distribution. And again, there's multiple years for some of these areas, but if you see just one value here, that's probably just 1 year and no additional data, but we can see the overall distribution and the variety or the variability in these smoking rates across different locations. So that looked fine, but let's say we're saying everything looked great, but you know what? I want to be able to read these labels. So you can actually add, by using the plus symbol, literally adding to a plot, things. You can change the theme, you can change the color, you can change a whole bunch of everything and anything you can think about these plots you can change. But here's one example where you say so coordinates underscore flip. So coord flip took this plot and actually flip the axes. It's an important distinction though. We kept X and Y exactly the same, but just flipped the coordinates. Now, if you changed and you said Y equals this, X equals this, and didn't flip the coordinates, it will not give you a plot that looks like this. It will give you something different. So sometimes it is useful to know how and when to flip the axes if you want, so that things can become more readable. There are ways, for example, to make these things, point down or diagonal, but we're not necessarily going to go into that in the summarization. So again, we should take a minute here and we're going to do some gross visualizations of the data to get some coarse looks at what's going on. So again, you can pause here, go to the lab, but we're going to move on with the lecture. So there are some base functions for plotting. So the plot function is very, very, very powerful. It does a scatter plot of X and Y, box plots, histograms, densities. I would say though, learning how to do this in qplot and ggplot2 is the best way going forward as a new beginner in R. So in conclusion, group by is a very powerful function, especially when used with summarize, also with mutate. The big difference between summarize and mutate, again, summarize will condense the data down into your summarization. Mutate keeps all the rows, but it will repeat a value over and over again if you have multiple, elements in that group. So sometimes, like for example, like I like to give the example of the baseline visit date, and you can then subtract the date of visit minus the baseline visit date, which is repeated over and over again for a patient. So this would be a new column of like days since baseline or something like that. And again, there's column means and col sums and row means and row sums, and the matrix stats package extends it if that's an intuitive framework for you. So there are additional slides in this lecture that we will not cover because generally they cover base R implementations or some different visualizations. You can flip through them. If they're not intuitive, just leave them be. Otherwise, this is the end of the lecture, and let's go back to the website. Thanks.